So remember, everybody, if you're finding that this is just the right amount of speed, just the right speed and the right amount of information, great. And if you're finding it's too much, just sit back and listen. Don't write anything, and you can watch this again and take notes another time if you want. Okay? You decide. So now what we're doing is we're taking a look at quadratics as well, but we're moving from graphing into the algebra and doing things like factoring, foiling, multiplying out brackets, and so on. So here we learned that when we have a binomial, we know bi means two, like bicycle, B-I-C-Y-C-L-E has two wheels. Binomial has two terms, and terms are separated by a plus or minus sign. So this is a binomial times a binomial. And when you have that, we expand by doing x times both of these, and then plus 3 times both of these. And the process we use is called FOIL. And FOIL stands for multiplying the first two, then multiplying the outside two, then multiplying the inside two, and then multiplying the last two. So that would be x times x, then x times 4, then 3 times x, then 3 times 12. First, outside, inside, and then the last two. We know that anything squared is the same thing, is something times itself, and then we can FOIL it out. And we also know that when we have area problems, we will have lengths and widths that we will have to multiply out, and we will be FOILing them. Okay, next we looked at standard form. So standard form is in the format of y equals ax squared plus bx plus c. Could be minuses or pluses, like this. There's an x squared, an x, and a constant. An x squared, an x, and a constant. And when we have this, we know that we can find out certain points and graph them. Later on, we figure out how to put this into vertex form, which makes it a million times easier to graph. Although this will highlight, this format does highlight what the y-intercept is, so that's convenient. And it, of course, tells you the over and ups or over and downs, and if it's opening up or down. And then we did more of those. And then we looked more at standard form. And then we started multiplying out brackets, right? 2x times x and 2x times minus 3. We remembered to do bedmass, so here it says 4x minus 2 times. So we did 2 times before we did 4x minus because of bedmass. We multiply before we add or subtract. We were shown that a negative in front of a bracket is really like -1 in front of a bracket. We were reminded that order doesn't matter with multiplying. So if you have 3 times 2 times 4, that's the same as 2 times 3 times 4, and it's the same as 4 times 2 times 3, and so on. So if you have 3 times that, you can FOIL these out and then multiply the 3 in. Or you could multiply in the single number here, in this case 2, and then FOIL the 2 brackets. Doesn't matter, both ways are fine. Okay, we then went and looked at factored form to standard form and how we just FOIL out the brackets and then collect terms. We looked at squaring out brackets and going vertex form to standard form. We talked about when standard form is useful and did some work with it. Then we looked at factoring. So we looked at factoring trinomials and common factoring, and we learned about how we factor depending on what the signs are. So first we look to see if the last sign is positive or negative, and then we do something. according to what it is. And once we look at this, then we look at this, and it also tells us something. Did more finding factored form, more finding factored form, summarizing parabolas, factored form, standard form, vertex form. And then we started doing some problem solving with factored form, or being given standard form and have to find factored form or vertex form, and more word problems. Okay, so now let's take a look at this question here. We're going to do a few quick things. First, what we're going to do is we are going to graph. If anyone needs graph paper, come on up and help yourself to a piece of graph paper. Okay, so I've got enough scaling done here. I've got arrows, I've got X and Y, and I've got one tick showing what each step is. So each tick is going to be 1 on the X and the Y axis. So if I'm asked to graph this, y equals 2 times quantity x plus 1 all squared plus 2. I want you to watch before you graph it to see the steps that I want, just to remind you the path to take. First thing is plot the vertex. So the vertex is negative 1, 2. Negative 1, 2. Make a point. Next, so I'll just make the points here. Vertex. Find it and plot it. Next is decide on your direction of opening. Is it up or down? And then 3, look at the vertical stretch or the over and ups or over and downs. In this case, is it up or down? Up or down? Up. Over and up. So I made my vertex, and then I'm going to go, because of the 2, I'm going to go over 1 up 2, make a point, and then over 1 up how much? Yep, over 1 up 2, over 1 up 6. 1, 2, 3, 4, 5, 6. Sorry, Mr. Y, I'm going to cut you in half. And then here I can use symmetry, right? There's that imaginary axis of symmetry here that's acting like a mirror. And then I'm going to connect the dots, and I have my equation right there. Here, I'm going to make this a little darker. That's it. No problem, right? If you know how to read the vertex, you can plot a vertex. If you know how to do over and ups or notice the direction of opening, you can notice the direction of opening. And if you know what your over and ups are or your over and downs are, graphing with table of values is a distant memory, right? It's like when you were little, you know that somebody held your hand when you went up and down the stairs, but those days are long gone. Same thing. Table of values, long gone. You don't need to do all that anymore. It's all done. Okay, now let's graph something in factored form. So if we're graphing in factored form, Let's graph that. Y equals negative quantity x plus 3 times quantity x minus 5. So you know that quantity stuff communicates that there's brackets. Okay, so the first thing is to plot our what? Plot those zeros. Number 1, plot the zeros, which are negative 3 and positive 5. 1, 2, 3, and 1, 2, 3, 4, 5. Next is what? Yeah, what's the axis of symmetry? Axis of symmetry is x equals what? That's negative 3. That's 5. Every tick is 1. What's the axis of symmetry? X equals 1. So from here is 3. From here is 5. 3 plus 5 is 8. Half of 8 is 4. So 4 from either end will be the middle. Now we have to find out when x is 1, what is y, so we can plot that vertex. So when x is 1, this is 4, this is minus 4. So what is, yep, negative times 4 times minus 4 is positive 16. So I'm going to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 like that. And I'm going to go like this and put a 16 there. To show it's going up to 16. Do you think I've clearly, oops, what did I do? Do you see my mistake? What is it, Bella? Yeah, it's not on x equals 1. I put it on x equals 0 because I got distracted by putting a number on the axis, the y-axis, didn't I? I think that's what happened. What do you guys think? Yeah. So let's fix that to 116. I'm going to put the 16 there. Erase this. That looks more symmetrical. Before it looked like someone had sort of sat on my curve on one side. That looks better, doesn't it? Yes? Okie dokies. So now I've graphed that. So that's how you're going to graph a parabola when given vertex form, and how you're going to graph a parabola when given factored form. Alrighty? Okay. Now, here's what I want you to do with all these word problems, because I think you're going to just zone out if I keep on just talking through word problems. What I want you guys to do is, we've gone through and we've taken up all these word problems. What I want you to do is look at them and try them on a separate piece of paper and see, can you do them? And then we can take up tomorrow what you can, I mean, we still have 20 minutes in class, so I can do it now also, but what you can do and what you cannot do. Now, what you can do, you can tell me, but what I really want to know is what you can't do. Because what you can do, you can tell me, and we can go like this, woo! Move on. Let's work on what we can't do while you're with me, and I can answer your questions. Okay? Now let's just have a quick